Hello everyone, my name is Kumari Tamang. Today we have a video presentation on MN692 research methods and project design. For this, we have a project titled Phishing URL Detection Application, and our group is Group 4. So here are the details of our clients. And our client is Dr. Abdul Mohammed with company AUS Private Limited. And for this project, we have our supervisor, Dr. Wanat Kumar, and tutor, Dr. Dipani Babarendra Guruj. So these are the requirements of our clients. So for they are looking for the phishing detection extension in Google Chrome with the use of fish tank and the different types of URL feature extractions with visual similarity features as well. And they are looking for the use of API and machine learning. And at last, we have our predictions for the results as well. So these are the group members for this project. Deepak Thapa is our group leader. Kumari Tamang, Lakshmi Thapa, Buddhiman Gurung, and Chatenbir Singh. This is the overview of our project. At first, we have our project design, then after working mechanisms of our project with the implementations and troubleshooting of our project as well with the achievements of the project. And at last, we have our conclusions and limitations. After this, my friend Buddhi will going to present the next slide. Thank you.
Thank you, Kumari. Okay, this is our project design diagram. Once the user inputs the URL, several features get extracted, such as domain-based features, etc. Google Safe Browser API checks the link whether it is present in the fish tank or not. For classification and analysis, a random forest classifier model is developed. This model predicts whether the website is safe or malicious, along with the percentage of accuracy. And this is the working mechanism of our extension. Preprocessor, training, exporter, they form the part of backend. Plugin UI and plugin controller form the part of front end. Plugin controller contains the content script, which is responsible for extracting the features from the website. Those features are sent to the backend for comparison and analysis. Once the result is confirmed, it will be displayed in the user interface. And here are the features which are being extracted, listed, such as IP address detection, a TCP port, a use of mail-to tag, use of iframe tag. Once the websites are analyzed, they will be classified based on the color and numbers. So green color indicates it is legitimate, and the number would be -1. Yellow indicates suspicious with number 0, and red indicate phishing with number 1. Next slide will be presented by my friend, Mr. Chatenbir.
Thank you, Buddhiman. So on this slide, I'm going to explain about random forest classifier, which been created for training and testing of our data, which is available with the ratio of 70% for training and 30% for testing. Random forest classifier is to predict the accuracy of phishing with the 95%. So on the right side, we have user interface design with efficacy, color coding, and features. So on this slide, the phishing website is being detected but not being blocked because of some code error in our tool. On the left side, you can see the typo error which being solved on the right side of the picture. On this slide, the phishing website being detected and also blocked, and a warning pop-up window being shown to the user. On the next slide will be explained by my friend Deepak. Thank you.
Thank you, Chidan, for your presentation. So this slide shows the achievements of our project. So we can see that our phishing extension is perfectly working, and it is detecting the accuracy of 88% of our website. And similarly, we can see on this slide that our extension is also capable of detecting the malicious website. Similarly, this slide represents how our extension blocks the phishing website, where we can see a pop-up message saying warning, phishing is being loaded. Similarly, this slide illustrates how our extension highlights the phishing websites. And there is also a small joke on the right-hand side where mom says she is tried to be fished by the fishes, and the son was kidding, saying, "Wait, really? No way, mom, haven't you installed MN692 guys phishing detection extension?" Finally, this slide shows the accuracy calculation and analysis for our project. So we have calculated precision, recall, and F1 score based on the true positives, false positives, and using the precision and recall. Basically, precision is calculated using the true positives and the false positive, whereas recall is calculated as using the true positives and false positive. And F1 score is the weighted average mean of precision and recall, where we can see the F1 score being 90%. So the next slide will be presented by my friend Lakshmi. Thank you.
Thank you, Deepak. I'm going to continue the next slide, which is SWOT analysis. SWOT analysis usually includes strengths, weaknesses, opportunities, and threats. Talking about the strengths, it can detect the phishing. It is able to scan all the external links. It is secured for the users, and it helps in maintaining their data privacy. Talking about the weaknesses, library assistance is not available, and our system does not support the external services like SSL and DNS. And for the opportunities, they are really good for the normal and the less educated staffs, since it helps in preventing them from unwanted phishing threats. And talking about the threats, some web browser plugin API will update continuously, which will create some inconvenience to the users as well. And moving to the next slide, we have got the conclusion. After the completion of our project, it will aware the user about the phishing websites. It helps in highlighting the malicious URL. It helps in predicting the website legitimacy. It helps in the calculation of F1 score. They are user-friendly. And they also block access to phishing websites that are fast and reliable. Here comes the limitations. Some of the limitations are it only supports the Chrome. Google Chrome has limitations to Python. User bypassing the phishing message can be compromised. Multi-threading in JavaScript is not available. API access to PhishTank needs to be upgraded. They can protect malicious JavaScript code from execution. They are less advanced in compared to neural network and deep learning. And here are some of the future works that needs to be done. Multi-threading is required. There is the need of deep learning and neural network. Extension in Python is required. Google's PhishTank database access limit should be updated. URL evaluation should be up to 30 features. And here are the references of our work. That's the end of our presentation, and thank you for listening to us. Thank you.